Welcome back, meteorology students. This is part two of week four's lectures. This is the last one. So today we'll be learning about dew and frost. We'll be learning about fog and also clouds and how we classify them. So let's get started. All right, so what is dew? Dew is where air near the ground cools to the dew point quickly, reaching saturation. This usually happens at night. You wake up in the morning and there's dew on the grass. I haven't really seen it around here very much, but I know in Nebraska I saw it a lot. Because at night we're losing all of that that heat at the surface, and so it cools there at the surface pretty quickly. And remember, the dew point is really where the temperature at which the air has to cool in order to reach saturation. So basically the temperature is cooled at the surface enough to hit saturation, and condensation happens because relative humidity is 100%, and you get these little water droplets that form on the blades of grass. Instead of having cloud condensation nuclei, it just condenses on the grass, and that's the thing that it actually condenses on. So you can see in this picture, you can see these little droplets of water on the grass. Water vapor, let's see, that's basically, it's called dew. So that's basically it. But the other thing that we have is frost. Now, this is when the dew point is actually below freezing. So say the dew point temperature is 28 degrees and the air temperature at night cools to 28 degrees. Well, then saturation would happen because it's hit the frost point, and it goes directly from the water vapor, the vapor phase, to the frozen phase. You remember, I think when I showed you the phase changes, there was a couple of them where it actually skipped a phase in between, and I said we won't even really talk about it very much. Well, this is pretty much the only time that we'll talk about it, and I think one other time, is when we're talking about frost, because the air actually cools down to that frost point to maybe 28 degrees, and it completely skips the water phase and then just goes straight into the ice phase. And it looks super cool. If during the winter time, you might open your door, you might be, I don't know, driving maybe early morning, and you'll see it just kind of looks like fields of white. It's really cool looking, actually. And that brings us to haze. And haze is when the relative humidity reaches around 75%. Now, there's certain cloud condensation nuclei that are what's called hygroscopic or water seeking. So it allows water vapor to condense on it when we haven't actually reached the dew point level. So it'll actually condense sooner than it would happen any other time. Now, when that happens, the droplet, eventually will get large enough to scatter light, and that's when we have a haze particle. It's not like a lot of water vapor is going to condense on this cloud condensation nuclei, similar to a cloud. So it'll be lighter, and that's why it's haze. It's not real deep or thick looking. It's just kind of like a I don't know, like a wispy look. Here's a picture of it right here. You can kind of see it. It's not so much like fog. Fog is thicker than that. This would be more like that. This is haze down here where you can still see through it because there isn't very many water droplets actually that will condense on that cloud condensation nuclei. Now, this is when we get to fog, and there's a few different types of fog. I'm going to go over the three main types of fog that you'll find. This is a picture I found, actually a friend of mine, Matt Grants, he has great photography, actually, that he does of weather phenomenon, and this is just a beautiful picture of some fog here. But fog occurs when the haze particles become visible to the naked eye, and it's going to be when the cloud is resting on the ground. So what is fog? If I ask you that, the answer would be a cloud on the ground. There's a place in San Francisco, and I don't remember where. I forget where. I think the Exploratorium you can go into, and they actually have like a cloud machine, and you can go into there, and they actually bring the temperature down to the dew point, and condensation happens, and then boom, you're standing in a cloud, which is basically fog. Okay, so the first type of fog is going to be advection fog. This is basically when air is over a warmer surface and then it hits a colder surface. And when it hits the colder surface, it's cooled down to the dew point And then fog is formed, well, basically a cloud, right? But it's a cloud on the ground. Now, this is what you commonly find in this area of the country, over, San Francisco, over areas on the coast. Now, I found, you guys might know this better than me, but when I was doing some research last year, I found that there is a name for the fog in San Francisco. Its name is Carl. This is a link. You can hit it if you go into it if you go into the lecture slides on Canvas, and it brings you directly to the Instagram page. And here, what is it doing today? See, pick of the week. Here it is. I think this was yesterday because I think I actually saw it on my newsfeed earlier today. Oh no, this must have been a while ago. Either way, you can go into his Instagram page, Carl, and it'll give you some interesting new pictures of the fog in San Francisco. And here's kind of a depiction of how that happens. The air is going to go over this warmer surface, and it'll be warmer. It'll hit a colder surface or the ocean, which is colder, and it'll cool down to the dew point, and then condensation happens, and that's when you see a fog. This is another great picture of the Golden Gate with some fog around it. Okay, and then another type of fog is going to be radiation fog, and this is going to form on a clear, calm night. Remember, on clear, calm nights, that's when there's going to be a strong inversion, and that's where you're going to find that layer right down at the ground being cold, like colder than it would be if there was clouds. Now, when that happens, it's going to be cold at the surface, and it'll get warmer with height, but that air, like right above that, is going to cool, and then cool to its dew point, and then it's going to hit saturation, and then what's going to happen, it'll look like a cloud. It will be a cloud on the ground, which is fog, and there you got it. That's basically how it happens. So these are very common in valleys because, remember we went over valleys. Down at the bottom of the valley, it'll be colder than it will be a little bit up further high. So it'll allow that air to get like colder down to its dew point. Here's kind of a picture of that and how that like works out for you. Here we have the heat rating from the surface at night, and it cools the bottom until the air reaches its dew point, until it reaches saturation. You can see right here. I've seen it definitely quite a few times in Nebraska. They can get pretty thick there in the morning. Okay, and then the last one we're going to go over is upslope fog. And this is basically the same thing as all the other ones. Remember, anytime you have a cloud, this basically going to be when the air just gets cool enough to hit its dew point temperature. And once that happens, then the outside temperature is the same as the dew point temperature, which is 100% relative humidity, which is also saturation. And then condensation happens, and then you have a cloud. So any type of cloud, fog, haze, anything like that, when you have some sort of condensation happening, then that's exactly what happens. Somehow, some warmer air is going to be advected. Remember the horizontal movement of temperature. It'll be advected along, and then it'll get cooled because it'll be over some other cooler surface. And this time, it's actually because it's going to be pushed up due to a hill or a mountain. All right, so it's going to actually be pushed up, and it's cooler the further up you go in the atmosphere, so it'll get cooler with height, and then all of a sudden it'll just hit dew point, and you'll see a fog. This happens commonly, like I said, on hills. I saw one recently when I was driving to San Francisco. I forget where I was exactly, but right before I got into San Francisco, there's kind of an area with like a hill over there, and I just saw some really cool upslope fog. I've seen it also, I live in Mountain View, so I've also seen it in the mountain. Obviously it's Mountain View, right? The mountain that I can see, to Santa Clara Mountains, but I don't know exactly which one. But you can kind of see it up there too. It's really sweet when you see it. Being from Nebraska, it's really flat, so I never really got to see it very often there. Okay, so here's your group questions. Please pause the video. Try to answer them on your own. I'm going to pretend like you did and move forward. Okay, so the first thing I like to kind of talk about when we get into clouds is that clouds actually has a place in society, and there's actually something called the Cloud Appreciation Society. I embedded right here, you can see, this is a link, so if you go to your your Canvas, the lecture slides on Canvas. You'll be able to follow that link if you're interested in it. Now, the Cloud Appreciation Society, I've read the book. It's a great book. It goes into all different places and cultures and things that are surrounded by clouds. The man who wrote it just kind of goes really into the fact that life would be boring without clouds because it would just be a clear, sunny sky every day. So you can see here that people, here's who took the picture. You can see people actually submit photos of clouds. You can go to clouds in video or clouds in art, clouds in music or poetry. So you can kind of look here. You can go into some like what people have painted and mailed, or not mailed, but uploaded in. Some really cool stuff here. So clouds have been around forever, and people have been talking about them for, here, look at a cloud spotter group if you ever want to join one. So I just kind of like to mention at this point that art and science, I think I've mentioned this before, there's a graying line between the two, and this is another place where I've seen, art and literature and some of these soft sciences be merged with the hard sciences. Sociology even. Okay, so going back to the science of clouds. So, like we said, if the relative humidity becomes close to 100%, the droplet that forms on the cloud condensation nuclei will get large enough to become visible to our eyes, which is a cloud. So some clouds will form higher up in the atmosphere and others on the ground, which we already went over is going to be fog, but closer to the ground. And a cloud is going to be a visible aggregate of water droplets or ice crystals suspended in the air. So it depends on how high up the cloud is as to whether it's going to be formed from water droplets or ice crystals. So here is... I was going to change these slides after last semester. I forgot to do it. Okay, so here is basically how we classify our clouds. There's going to be a few different major cloud types. So if I was to ask you things about the cloud height, this is going to be the things over here in the right-hand column that I'll be looking for. Let's start with the low clouds. These clouds are going to be under 2 kilometers, and any type of low cloud, we'll start with the word strat. So stratus, stratocumulus, or in this case, it ends with stratus, but nimbostratus. Now, these are going to be made of water droplets. You're not going to find any ice crystals in there. Now, middle clouds are going to be 2 to 7 kilometers, and they're going to have the term alto in it. So altostratus, altocumulus, things with the word alto are going to be in the middle of the atmosphere. These can be a combination of water molecules, or water as well as ice. And the high clouds, which would be 7 to 10 kilometers, are going to have the term cirr in it. So cirrus, cirrostratus, cirrocumulus. These are going to be clouds that are higher up in our atmosphere, and these will always be consist of ice crystals. So there's going to be a couple other things that we can classify as well. One of them is going to be the clouds producing rain. Those are going to have the word nimb in it. So nimbostratus. A nimbostratus is going to be a cloud that is low to the ground and produces rain. Another one is going to be cumulonimbus. So nimbus is always in this, and that means that rain will be involved with that cloud. Now, the last one is going to be clouds with vertical development. That one will be a cumu. So this cumulonimbus is going to be a rain cloud that has vertical development. Cumulonimbus clouds are the ones that are thunder and lightning clouds. These are the ones where you'll find severe weather, tornadoes, hail, things like that, because they have this really vertical development to them, but they also obviously have rain. This kind of right here is what I just explained about the height categories. And see, these ones that have the vertical development, they don't have a vertical category to them, because they will go from the low to the high. They have this like vertical piece to it, so they're going to cross over between levels. So here's a picture of some of these different cloud types and where you'll find them in the atmosphere. So here's like our stratus and our nimbostratus, And our cumulus. Cumulus clouds are going to be like I call them Simpson clouds because, you know, the beginning of The Simpsons, like what those little clouds look like. Or they call them fair weather cumulus, that kind of idea. We can see the altostratus or the altocumulus here in the middle. And then here at the top, these ones are the glaciated ones. These are the ones made of ice. You can see the cirrocumulus and the cirrus. And then you have the cumulonimbus. That's this one right here. This one encompasses, see, all three levels, and you can see the rain underneath it and then the lightning. So this one's got severe weather associated with it. All right, so here's some pictures of some cirrus clouds and some cirrocumulus clouds. These look really wispy in nature. It's because of the ice. The ice really just gives it that wispy, kind of like you painted it onto a canvas. You know, and these cirrocumulus will just kind of look like little, I don't know, cotton balls kind of stuck together. And these are going to be altocumulus and altostratus. So these are going to be the ones where, you know, it has some vertical development to it in the middle of the atmosphere. And altostratus are very thick clouds. You can't really see through them. And then these are going to be stratus clouds. You can see, like, stratus clouds, you really can't see the sun through them at all. They're just real, you know, they reflect a lot of that incoming solar radiation. So they're really thick and you just can't see very much through them. And then we have stratocumulus ones over here, which are lower to the ground, but also have some vertical development. This, by the way, is going to be a picture of a National Weather Service station, just so you can kind of see what one looks like. This is going to be what the radar actually looks like, the Doppler radar. This is exactly what they do. I mean, see, there's the stairs going up to maintain it. Looking to see if there's anything else I can point out to you guys here. I can't see anything else right now, but this is basically what they look like. You know, this is the transmitting station, so they can transmit things that they need to. All right, and then here's what a cumulonimbus cloud looks like, you know, from the air. You can really see how this really has some vertical development to it. It really has got these strong updrafts going in there. And then there's the anvil here. These are our thunderstorm clouds. And then there's some that just don't, like, they're not really classified in those classification systems. They're just kind of unique to themselves. And this one is actually a mammatus cloud. These you will very typically find with severe weather. These are really cool looking clouds if you see them actually occur in nature. I don't think I've ever seen them around here, but I've definitely seen them while chasing tornadoes before. I've seen them one time where they were yellow, and they were really cool. So, and this one's going to be a lenticular cloud. These actually occur over mountains a lot. You guys might have, I've never seen them. I keep looking for them around here over the Santa Clara Mountains, but I actually haven't seen them. This was taken by Craig Clements. He's one of our fire weather guys here in our department. Okay, and then just a side note, these are going to be contrails. Contrails are produced by the exhaust coming out of an airplane. So the exhaust coming out of the airplane is going to be warm, and it's going to higher up in the atmosphere, so it's colder air up there. So it's going to be shot out of the airplane, and then what's going to happen is that the exhaust is going to cool to its dew point temperature, and it's going to hit relative humidity and become saturated, and then condensation will happen, and then it'll produce kind of like its own cloud due to that whole phenomenon. So this is not, you know, the government trying to control us. I don't know. I've heard a lot of people ask me about chemtrails, you know, chemicals. If you're not familiar with it, those are chemicals that are come out of the tail end of airplanes, and it is a contrail, but that's basically, it's not chemicals. It's just physics. And then here's some, you know, I took both of these pictures. This one was when I was storm chasing one time. This is in Omaha, Nebraska. This is another one I took one time when I was in Las Vegas. I took these two pictures and put them on this because sometimes you just don't know what you're looking at. I'm not sure what this would be right here. This right here would be mammatus-ish clouds, but I feel like the clouds are kind of like in between, so it would be hard to call exactly what it is. If you're interested in clouds, this is another link that kind of shows you 20 amazing cloud formations if you want to see. There's some really cool pictures out there of clouds that you can find. And here's the group questions. So I encourage you guys to go over these again, like always. And that concludes our video for the week. And I hope you guys have a terrific week. And thank you.